Here I have a problem from the LSU math contest in the year 2015, and this is number 23 in that contest. And it asks us to find the largest positive integer n such that 2 to the nth power divides 20 factorial. And I have a little note written in red here that tells us we only need even numbers because odd numbers don't have any copies of 2, which is what we're looking for here. We have 2 to the nth power. So I think the easiest way to do this is just to split up 20 factorial and look for all the copies of 2 within it. So let's go ahead and write down all the even numbers from 20 factorial. I'm going to go ahead and put that list on the board now. Okay, so here we have all the even numbers contained within 20 factorial. And now we want to look for all the copies of 2 within these numbers. So 20 is going to give us 2 copies of 2. That's from the factor 4, but then 4 splits into 2 copies of 2. And the other factor in that case would be 5. But 5 doesn't contain any copies of 2, so this number is good. 18 contains 1 copy of 2, that's from 2 times 9. And then likewise, 9 doesn't contain any copies of 2. 16 contains 4 copies of 2, that's because 16 breaks into 2 times 8, and then 8 breaks into 2 times 4, and then 4 breaks into 2 times 2, and that's 4 copies of 4. 14 breaks into 1 copy of 2 and 1 copy of 7. 12 breaks into 2 copies of 2 and 1 copy of 3. 10 breaks into 1 copy of 2 and 1 copy of 5. 8 breaks into 3 copies of 2, similar to 16, but just with 1 less copy. 6 breaks into 1 copy of 2 and 1 copy of 3. 4 breaks into 2 copies of 2, and 2 itself is a copy of 2. Okay, but now what we want to do is just add up all of these copies of 2, and that tells us the total number of copies of 2 within 20 factorial, which is what we're looking for. We're looking for the largest number n, such that 2 to the n divides 20 factorial, and that largest number is going to be all of the copies of 2 within 20 factorial. So what we want to do is just add all these up, and we'll have our n. Adding up all these exponents here, we get 2 to the 18th, which tells us that n equals 18, or 2 to the 18th divides 20 factorial. And we've proved that that's the largest positive integer n, because we've taken all of the numbers within 20 factorial that contain a copy of 2, and we've added them all up. Okay, that's enough for now.